the sweltering heat of Guidonia Airfield near Rome during June 1943, Ingegnere Capo Filippo Zapata mopped his forehead while slowly walking around the plane positioned on the apron, watched over by soldiers with rifles. This American twin-tailed pursuit aircraft shone brightly beneath the intense Mediterranean sunlight, its sleek aluminum fuselage showing no damage beyond minor scuffs from the forced touchdown in Sardinia just 3 days prior. A mistake in course plotting had unexpectedly handed this engineering marvel over to Italian forces, a fully operational Lockheed P-38G Lightning, its pair of Allison power plants still radiating heat from the journey northward. Upon his initial glimpse of the P-38 parked there, Zapata's response echoed that of his fellow aviators in Italy. Its clumsy configuration, with those protruding booms on either side of a main cockpit pod, clashed against the refined aesthetics prized in Italian aircraft. Fellow officers dubbed it Il Diavolo, a do code, the devil with twin tails, though the term held more ridicule than genuine dread. Yet, as Zapata commenced his careful inspection, the specialist who trusted in precise calculations stood on the brink of a staggering realization. Far from being clumsy, the P-38 embodied a vision of the future, and its intricate parts offered irrefutable evidence through sheer metrics that Italy was already defeated in a conflict its commanders clung to the hope of prevailing in. As the Regia Aeronautica's leading expert on aircraft propulsion, Zapata had devoted a decade and a half to developing and assessing power units for companies like Fiat, Alfa Romeo, and Isotta Fraschini. He had scrutinized seized British Spitfires, delved into Soviet Yaks, and dissected German Messerschmitts. In his view, he possessed a solid grasp on the advancements in aeronautical technology as of 1943. He stood on the brink of realizing his ignorance ran far deeper than he imagined. While his group of technicians advanced toward the Lightning, carrying their kits of tools and diagnostic devices, Zapata found himself gripped by an unshakable unease. The United States had transported this aircraft over vast seas to engage in a conflict raging thousands of miles from its shores. This feat by itself hinted at a manufacturing prowess that Italy struggled even to grasp. Yet it was the secrets hidden under the coverings of those power plants that would uncover a reality so crushing it would linger in the minds of Italian aircraft specialists throughout the rest of the conflict. They weren't merely lagging. They were utterly, hopelessly surpassed. The P-38 Lightning embodied all that Italian aircraft design lacked. In contrast to the sleek, featherweight Italian interceptors, which extracted peak efficiency from scarce materials, the Lightning emerged as a sheer American powerhouse, heavy, intricate, and driven by propulsion systems beyond the reach of Italian production lines. Zapata was familiar with the details through hearsay. Twin Allison V-1710s, V-1710-1910 engines, supercharged contra-rotating blades, tricycle undercarriage. In theory, it appeared downright extravagant. Dual motors when a single one would do. Pointless elaboration. Classic Yankee extravagance. However, Zapata operated as an engineer, and engineers rely on evidence, not mere word of mouth. The team placed their faith in precise measurements. For the initial hour, Zapata's group focused solely on cataloging the aircraft's outer specifications. The P-38 Lightning boasted a wingspan of 52 feet, a span that seemed fitting for a combat interceptor. Yet the mass proved astonishing. Through structural assessments and estimates of fuel volume, they determined the fully burdened weight approached 18,000 pounds, roughly double the heft of Italy's premier interceptors, such as the Machi C-202 and the Fiat G55. "How could an aircraft this massive take to the skies?" murmured Assistant Giorgio Mancini while jotting down the figures. "That's precisely what discovery awaits us," Zapata responded, even as he anticipated a revelation that might prove disturbing. True scrutiny commenced once they unlatched the engine enclosures. They started with the port-side power plant. As the covers parted to expose the Allison V-1710, a hush descended over Zapata's engineers. The engine's scale alone, with its 12-cylinder liquid-cooled V layout, dwarfed anything familiar to Italian designs. Nor was it merely the exceptional craftsmanship that silenced them. Despite the flawless polish on every part, a level of refinement unattainable in Italy's workshops, hampered by scarce resources and relentless strikes from Allied bombers. What truly captivated them was the turbo-supercharger setup. Intelligence briefs had acquainted Zapata with U.S. advancements in turbocharging. The principle itself was familiar, harnessing exhaust fumes to drive a turbine that boosted incoming air pressure, thereby sustaining ground-level output even in thin upper atmospheres. German technicians had tinkered with such devices, while Italian designers had sketched ambitious plans. However, no nation, not the Germans, not the British, and least of all the Italians, had managed to incorporate a turbocharger into an operational fighter plane. Only the Americans had achieved that feat. They struck it 2 times, once per power plant, and production lines were churning out scores of these planes on a monthly basis. Positioned aft and beneath every motor, the supercharger unit linked up via an intricate web of piping for waste heat that wove its way along the rear fuselage framework. Upon close inspection by Zapata, the impeller proved to be a triumph in metalworking. An expertly shaped part meant to whirl at speeds surpassing 21,000 rotations each minute, all while enduring blast temperatures that topped 700 degrees Celsius. "What kind of metalwork is this?" inquired Mancini, tracing his fingertips along the impeller vanes. Zapata responded with a deliberate shake of his head. "Maybe nichrome, or some custom blend. No matter the composition, it's beyond our reach. And supposing we somehow obtained the substance, we'd still be missing the advanced molding expertise required to produce it." The consequences hit like a thunderbolt. Every engine in the P-38, equipped with its sophisticated turbocharger setup, generated around 125 horsepower when operating at war emergency levels. Together, they delivered more than 2,250 horsepower in total. To put this in perspective, the Daimler-Benz DB605 that drove the cutting-edge Machi C-205 FV, Italy's top fighter aircraft at the time, output 1,175 horsepower. Thus, a single P-38 boasted almost double the might of the finest single-engine plane Italy had to offer. Yet the disparities only grew more daunting from there. Zapata set to work, crunching the numbers on what it would take from an engineering standpoint. The Allison V-1710 had a displacement of 1,110 cubic inches, equivalent to 28 liters. The exacting craftsmanship demanded for crafting its 12 cylinders, 12 pistons, connecting rods, a crankshaft built to endure 3,000 RPM amid the stresses of battle, the supercharger, the turbocharger, the intercooler, the oil cooler, the cooling system, the radiator, and the reduction gearing. All of it seemed overwhelming. Reaching for his notebook, he began jotting down the array of parts involved. His assistant observed in silence for a moment before voicing the doubt hanging between them. Were they capable of constructing such a machine? Zapata kept scribbling away for a few more minutes before he responded. Assembling just one. It might be feasible. Given half a year, boundless funding, their most skilled fabricators, and ideal circumstances. Producing it consistently without flaws? Out of the question. Manufacturing hundreds? Utterly unfeasible. The ingenuity of American engineering shone through in the cooling setup by itself. Employing liquid cooling, the Allison featured remote radiators positioned along the leading edges of the wings, a clever placement that reduced aerodynamic drag to a minimum while boosting the effectiveness of heat dissipation. These radiators consisted of meticulously crafted cores, incorporating countless narrow tubes joined together via brazing to ultra-precise specifications, ensuring no leaks occurred even as they optimized the exchange of thermal energy. In contrast, Italian radiator designs trailed far behind in development. Their versions proved bulkier, far less effective, and highly susceptible to damage during battles. The U.S. approach incorporated built-in armor shielding, backup pathways for the coolant, and a glycol blend capable of functioning at elevated temperatures beyond what Italian setups could endure. As Mancini ran his finger along the coolant conduits, he remarked, "They've tackled issues we weren't even aware of." Zapata interjected with a refinement. "They've tackled issues we were fully aware of, but lacked the resources to resolve." An additional dimension of intricacy came from the counter-rotating propeller arrangement. The engine on the left turned in a clockwise direction, while the one on the right spun counterclockwise, thereby neutralizing the torque reactions that often troubled aircraft with just one engine. Achieving this demanded reduction gearing configured as mirror images, distinct governors for each propeller, and meticulous alignment between the two power plants. Inspecting the reduction gearing closely, Zapata noted its exacting construction, which stepped down the engine's 3,000 RPM to roughly 1,400 RPM at the propeller shaft. Forged from hardened steel and machined to extraordinary precision, the gears featured clearances calculated to mere thousandths of an inch. Domenico Russo, the team's metallurgy expert, stated bluntly, "We couldn't produce gears like these, not given the quality of steel we have now, not with the heat treatment methods at our disposal. These components must handle 1,500 horsepower reliably, without breaking down. Ours would shear apart under only half that power." During the ongoing inspection, a troubling trend became apparent to Zapata, one that unsettled him even more than any isolated feature. The P-38's every subsystem had been engineered for backup reliability, ease of upkeep, and adaptability in action. Its electrical setup relied on a 24-volt framework equipped with duplicate generators, one attached to each engine, so that should one give out, the remaining unit could sustain every critical function. In contrast, Italian pursuit planes operated on 12-volt setups, featuring just a lone generator. The hydraulics, responsible for deploying the landing gear, flaps, and dive brakes, featured backup pumps, along with several circuit breakers for protection. Italian aircraft, by comparison, typically depended on manual linkages or fragile single-line hydraulic arrangements prone to battle harm. The fuel arrangement included puncture-resistant tanks, a method Italy had just started adopting, along with intricate transfer options that enabled shifting fuel across tanks or engines, or isolating them to conserve resources for the crew in emergencies. Yet, it was the sheer volume of munitions that left the Italian specialists reeling. The P-38 packed a single 20mm Hispano cannon loaded with 150 rounds, plus 4 Browning M2 .50 caliber machine guns, each holding 500 rounds, with all ordnance clustered forward in the fuselage. This amounted to 1 cannon, and 2,000 rounds of potent machine gun fire in total. The Machi C-205V, on the other hand, mounted 2 12.7mm machine guns with 400 rounds apiece and a solitary 20mm cannon carrying 200 rounds. Thus, the P-38 boasted triple the ammunition load and far greater destructive force. "They've constructed an aerial warship," remarked Mancini, as he scrutinized the loading tracks for the guns. "Observe these delivery mechanisms. They're built to operate smoothly amid extreme G-forces, free from malfunctions." He indicated the electric drive units for the ammunition boost, adding, "These devices guarantee steady supply even as the flyer endures 6 Gs during a sharp bank." Filippo Zapata scribbled notes at a frantic pace, yet he had abandoned the task of documenting technical details. His focus had shifted to estimating the demands of mass production. A single P-38 demanded around 50,000 separate components. Just the engines incorporated more than 6,000 pieces apiece. The wiring for the electrical setup stretched across 8 miles. For the hydraulic setup, it needed finely crafted valves and gaskets that suppliers in Italy proved unable to deliver consistently. The structure of the aluminum fuselage called for metal blends that Italy found increasingly hard to secure, hampered by scarcities of raw materials and blockades imposed by the Allies. Lifting his eyes toward the Lightning positioned on the runway, Zapata experienced, for the first time in his professional life, a profound sense of hopelessness. This went beyond being merely a foe's plane. It stood as proof of a sweeping industrial transformation that Italy had failed to keep pace with. Later that night, from his desk at the Guidonia facility, Zapata started composing his evaluation. The portion on technical details spanned 12 pages, covering dimensions, breakdowns of parts, evaluations of substances used, and estimates of operational performance. However, he recognized that the concluding part, labeled Strategic Assessment, was bound to stir debate. In it, he stated, "The Lockheed P-38 Lightning embodies an advanced degree of aircraft design expertise that outstrips Italy's production abilities by roughly 5 to 7 years, given our present progress. Even more tellingly, this plane highlights the vast scope of U.S. manufacturing power, which operates on a level beyond our reach." Specific findings. The Allison V-1710 engine, equipped with turbocharging, delivers 1,425 horsepower, a figure that rivals the output of our strongest power plants, while offering markedly better performance at high altitudes thanks to its turbocharger. Within Italian manufacturing, the necessary expertise in metallurgy, exacting machining processes, and rigorous quality assurance simply does not exist to duplicate such an engine. Assembling even one experimental model would demand a full 18 months of effort and would drain away the materials and labor essential for building 20 standard fighter planes. Just the turbocharger mechanism embodies advancements that surpass what our engineers can currently achieve, relying on unavailable resources like specialized materials, advanced scientific knowledge, intricate casting methods, and alloys capable of withstanding extreme heat. The counter-rotating propeller setup effectively counters torque issues, yet it depends on finely tuned reduction gears that our facilities struggle to produce with any consistency. In the aircraft structure, the use of aluminum alloys and shaping methods reveals a level of sophistication that outstrips our own practices. Moreover, the way the various components, ranging from electrical and hydraulic systems to fuel delivery and weaponry, are combined reflects a design mindset that favors built-in backups and ease of upkeep rather than minimizing mass. Such a strategy becomes feasible solely through the availability of engines potent enough to offset the added heft. U.S. production methods seem well suited to churning out these intricate machines on a massive scale without compromising their excellence. Reports from intelligence sources indicate output surpassing 200 units per month across several plants. By way of contrast, Italy's overall monthly production of fighters, encompassing every variant, hovers around 150 planes, and this figure continues to drop amid supply constraints and strikes from Allied air forces. The P-38 defies any attempt at matching it through equivalent technology. Fighters from Italy suffer from insufficient engine strength, diminished high-altitude capabilities, and inadequate armament to challenge it successfully. Doctrine for tactics ought to prioritize steering clear of confrontations with P-38s whenever feasible. In terms of broader strategy, should this plane exemplify the standard of U.S. manufacturing prowess, and reports from intelligence indicate that it does, then Italy confronts a foe boasting vast industrial dominance. Victory in the conflict proves impossible via a war of wearing down such an adversary, one that can churn out advanced weaponry like this in vast quantities. Zapata reviewed the document on his report no fewer than 3 times prior to affixing his signature. The engineer anticipated the outcome all too well. His detailed technical analysis would likely gain approval, while the broader strategic evaluation would be brushed aside as overly pessimistic. Yet, as a man of science driven by hard data and precise calculations, he could not ignore the irrefutable facts staring him in the face. Come the following dawn, Colonnello Angelo Tondi, who served as the Regia Aeronautica's lead test pilot, made his way to Guidonia to take the controls of the seized Lightning. Tondi brought with him a wealth of experience, boasting thousands of flight hours across numerous aircraft models. He had piloted the full range of Italian fighters, along with interned Spitfires and even a Messerschmitt Bf-109. During Zapata's thorough technical rundown, Tondi maintained a polite, professional demeanor, though the look on his face implied he suspected the engineer might be exaggerating the aircraft's capabilities. After all, American designs were renowned for their heft. It was common knowledge. They prioritized mass production above finesse, raw power instead of graceful engineering. With the assurance of someone who had tamed every plane he had ever encountered, Tondi settled into the P-38's cockpit. From his vantage point in the control tower, Zapata observed as the Lightning's power plants came to life. One on the left side, followed by the one on the right. The Allison V-1710 engines soon hummed in perfect harmony, their steady vibration rattling the tower's glass panes. Tondi guided the aircraft along the taxiway with deliberate care, getting accustomed to the tricycle undercarriage and the steering provided by the nose wheel. To those watching who were accustomed to the swift departures of Italian fighters, springing airborne almost instantly, the runway run felt endlessly drawn out. Nevertheless, Once the Lightning lifted its nose and began its ascent, it surged upward at such a steep pitch that it left Zapata momentarily breathless. After just 15 minutes in the air, Tondi brought the plane down for a landing, rolled it back to the parking area, and cut the engines. He remained seated inside for a few long moments before descending from the cockpit. Upon touching solid ground at last, a noticeable shift had overtaken his features. Making a beeline for Zapata, he spoke in a subdued tone. "Your entire report holds true," Tondi admitted, "and in certain aspects, you actually downplayed the reality. Up high, this machine proves impossible to match. Even at 25,000 feet, it kept gaining speed. Its rate of climb surpasses anything I've ever encountered. The handling feels superbly balanced, weighty yet impeccably accurate. Visibility stands out as exceptional. As for the armament—" He hesitated briefly. I unleashed a trial salvo. It roared like a storm breaking loose. The nose-mounted cannon alongside 4 machine guns, all unleashing without any synchronization problems. Simply aim the plane toward the objective and squeeze the trigger. Whatever lies ahead perishes. Zapata inclined his head thoughtfully. Is there a way to oppose it? Tondi remained quiet for an extended pause. Nothing in our current arsenal can do it. Nothing in our pipeline either. The Mach-E C-205V performs brilliantly at medium heights. The Fiat G55 boasts solid armament. Yet neither rivals this U.S. interceptor in the domain that defines contemporary aerial warfare. Elevated altitudes, rapid velocities, prolonged engagements. And you're telling me they're manufacturing them in large numbers? Spy reports project 500 units monthly come late 1943. Tondi let out a chuckle, yet it carried not a trace of amusement. 500 of those things every single month. And what do we manage to churn out? Maybe 50 Mach-Es and 30 Fiats in our best month? Meanwhile, they're cranking out thousands of B-17s and B-24s, P-47s, P-51s, ships, tanks, you name it. His gaze returned to the Lightning. This is the kind of country we're up against. One with the resources to install a pair of 1,400 horsepower turbocharged engines into just one fighter, and then manufacture hundreds more. What does that say about the scale of this conflict? Zapata offered nothing in reply. The point was meant to hang in the air regardless. In the weeks that followed, Italian technicians carried out thorough evaluations of the seized P-38. They pitted it in flights versus Italian interceptors across a range of heights and velocities. Its capabilities were assessed during ascents, plunges, and maneuvers. The aircraft's components were then evaluated alongside comparable designs from Italy and Germany. All evaluations yielded the identical grim result. The Lightning outperformed rivals across nearly all quantifiable aspects. In the skies beyond 20,000 feet, the realm of bomber escorts, no aircraft from Italy's arsenal possessed the capability to pursue it. While Italian power plants faltered in the thinning atmosphere, the turbo-superchargers sustained peak output without compromise. Remarkably, even the German Bf-109G, powered by its DB-605, experienced a sharp decline in capabilities past 25,000 feet. It was precisely in that high-altitude domain that the P-38 truly excelled. This edge in velocity empowered its pilots to dictate the terms of battle, deciding whether to press the attack or withdraw at will. When Italian interceptors gave chase, U.S. aviators could effortlessly shake them off by advancing the throttles and accelerating beyond reach. During simulated engagements, the clustered firepower in the aircraft's forward section delivered overwhelmingly lethal results. In contrast, Italian machines armed with weapons in the wings grappled with synchronization problems. Their armaments were usually calibrated to intersect at a distance of 300 meters, rendering them suboptimal at varying distances. The P-38's forward-positioned guns faced no such constraints. Simply aim and fire. Yet, the revelation that most unsettled the Italian technicians emerged during their meticulous teardown of parts for closer inspection. The craftsmanship was nothing short of exceptional. The craftsmanship in the welds stood flawless. Precision defined every machining process. Top-quality materials formed the backbone of the entire structure. Nowhere did builders cut corners, yield to limitations, or show signs of scarcity in supplies. One Italian engineer, scrutinizing the engine, jotted down observations that captured the essence. Each part seems constructed with an excess of robustness, incorporating safety buffers beyond our financial reach. In contrast to Italy's approach, which squeezes maximum output from scant resources, the United States relies on exceptional raw materials and production techniques to deliver results. Our engineers push boundaries to the absolute limit of feasibility. Theirs incorporate redundancies that anticipate potential breakdowns, ensuring the plane remains airborne regardless. This mindset permeated every aspect of the airplane's design. Framework elements carried extra heft beyond bare essentials, enhancing resilience against wear and injury. The wiring setup featured additional fuses and backup pathways far exceeding what Italian specialists would deem practical. Protective sheathing encased the fluid conduits, increasing mass yet vastly boosting the odds of enduring combat damage. Such methods reflected the ingenuity of a country flush with boundless assets, and the results proved effective. The renowned resilience of the P-38 owed nothing to chance. Designers had woven it into the very foundation. Zapata's evaluation ascended through the ranks of authority. Its engineering details circulated among Italy's aviation firms, with directives to pinpoint adaptable innovations for upcoming projects. The broader implications landed on the desk of Maurizio Dell'Aria Rino Corso Fugi, head of the Italian Air Force. Fugi pored over it with attention, only to archive it without action. No viable steps existed. Italy simply did not possess the manufacturing prowess to match U.S. advancements. The most skilled Italian technicians could manage was refining current models, banking on aviators' expertise and innovative maneuvers to offset hardware shortfalls. Yet that approach fell short in the end. It was an open secret among those in the know, yet no one dared voice it aloud. On that fateful day of August 11, 1943, Tondi took the seized Lightning into actual battle. Reports from intelligence indicated a group of US B-24 Liberators heading back after their raid on Terni. Departing from Guidonia, Tondi ascended to a suitable height and maneuvered into striking position. By leveraging the aircraft's recognizable outline to approach without detection, he unleashed his assault on a lagging bomber. The devastating barrage from the cannon combined with the 4 machine guns ripped through the Liberator. Tondi registered the victory, which records variously attribute to a B-24 called Bonnie Sue or the Lady Evelyn amid the discrepancies. This marked a minor triumph at best. An enemy fighter, now in Italian hands and piloted by the nation's top test flyer, had managed to down a single U.S. bomber. In terms of boosting morale through publicity, it served a purpose. From a broader military standpoint, however, it held no real weight. Before long, the Lightning was sidelined permanently. Lacking replacement components, absent any service guides, and deprived of the supply chain that sustained U.S. P-38s in the air, the appropriated plane turned into little more than a forgotten relic in storage. Tandy would not pilot it once more. The conflict pressed forward unabated. In September 1943, Italy capitulated to the Allies. The prototype Lightning stationed at Guidonia came under German control shortly thereafter, only to be deliberately demolished later in order to avoid any possibility of it being seized again. Remarkably, Zapata's detailed assessment endured within archival records, serving as a pivotal engineering analysis that captured the instant when Italian specialists grappled with the overwhelming scope of U.S. manufacturing prowess and realized they had no effective countermeasure. Once wartime output statistics were released following the conflict's end, it became evident that Zapata's projections had understated the reality. Across every model, the United States manufactured a total of 10,037 P-38 Lightnings. Power in each aircraft demanded a pair of Allison V-1710 engines, resulting in 20,074 such units solely for the Lightning initiative. Beyond that, the Allison V-1710 powered additional fighters like the P-40s, P-39s, and P-63s. In all, more than 70,000 of these engines rolled off assembly lines. By contrast, Italy's complete output of airplane engines during the war, encompassing every variety and producer, amounted to roughly 13,000 examples. The Americans, in turn, had generated 5 times that volume from just one sophisticated engine design alone. This gap permeated all aspects of the conflict. During the war, the United States manufactured more than 300,000 planes. In contrast, Italy managed to produce around 11,000. Just the aluminum output from America in 1943 surpassed the full extent of Italy's production throughout the entire war. In U.S. factories, laborers, often women stepping into manufacturing roles for the first time, put together intricate airplanes with an accuracy that outpaced the efforts of skilled Italian artisans. Decades afterward, during the 1960s, an expert in Italian aviation history sat down with the now-retired engineer Filippo Zapata to discuss his inspection of the seized P-38. Thoughtful in his later years, Zapata recounted that pivotal moment from June 1943 with measured words. "The realization hit me that we'd be defeated the instant I lifted those engine covers," Zapata recalled. "It wasn't due to one particular piece, but rather the broader significance of the plane itself." The U.S. had engineered a pursuit aircraft demanding 50,000 components, among them a pair of the era's most sophisticated power plants, and they were churning out such machines in volumes that dwarfed our capacity even for our most basic models. As I tallied the labor hours, the raw resources, the exacting fabrication processes, and the rigorous standards of oversight needed, the truth emerged. We were up against a manufacturing powerhouse that had only just started gearing up for full effort. The P-38 wasn't even their top pursuit plane. It stood as merely one among multiple cutting-edge variants they were fabricating at the same time. While our output limped along at barely 100 fighters each month, they were turning out thousands, everyone matching or surpassing the quality of our finest creations. The interviewer then inquired, "Were you ever able to take a flight in a P-38? Zapata gave a faint smile. "No," suggested Tandy, "but I turned it down. As an engineer rather than a pilot, I had no need to take it airborne myself. The calculations revealed all I required to know. factors like the power-to-weight balance, the wing loading, and the comparison between available thrust and necessary thrust. The equations governing aerial capabilities show no mercy. The P-38 excelled in power, high-altitude operations, armament, endurance, and onboard equipment. It simply outperformed the competition, with thousands in service. The seized P-38G at Guidonia barely entered meaningful frontline use. It completed just a few evaluation sorties, joined a single battle operation, and afterward remained idle in storage as a mere object of technical interest, a symbol of a conflict that Italy had already forfeited, scrutinized by technicians who grasped its broader significance, yet could do nothing to alter the course. In the end, the tale of this appropriated lightning boils down to manufacturing prowess and the unyielding logic of aviation engineering. It encapsulates the essence of contemporary conflict. When Italy joined the Second World War, it boasted talented airplane architects, proficient aviators, and a storied legacy in the skies. Yet it fell short on the factory networks needed to match U.S.-style volume output. It wanted the raw supplies to perfect innovations such as reliable superchargers. It missed the alloys for constructing with the same reliability buffers as the Americans. And it had no window to bridge an ever-growing divide as the months dragged on. In Filippo Zapata's detailed account, this harsh truth emerged through exact technical specifications. The aircraft featured a pair of Allison V-1710 power plants, delivering a total of 2,150 horsepower. Its turbo-superchargers ensured peak output, equivalent to ground level, even at altitudes of 25,000 feet. The design incorporated contra-rotating propellers to neutralize any torque issues. Up front, it packed focused firepower backed by 2,000 rounds of ammo. The overall setup emphasized built-in backups and seamless component harmony, favoring reliability in action rather than shedding pounds. Underpinning everything stood a vast manufacturing powerhouse, churning out such intricate fighters in volumes that dwarfed Italy's output to near irrelevance. That seized P-38 lingered on the Guidonia Airfield for just a brief span of months. Yet, to the Italian specialists who scrutinized its every part, took precise measurements, and pondered its broader consequences, the plane marked a pivotal shift. It signaled the instant when cold, hard calculations eclipsed hopeful battlefield strategies. From that insight, they grasped the true nature of the conflict. Victory would hinge not on bravery or expertise alone, but on the might of production lines, raw materials, and sheer output scale. The United States possessed ample supplies of each. Italy lacked them entirely. The P-38, dubbed Lightning, stood as irrefutable evidence. And even the brilliance of Italian ingenuity offered no way to alter such an unyielding truth.